Are you sure your APIs are secure? An introduction to API security testing. I can't explain anything more about Bas. He's a great guy. We've worked with him and had him at TQ in the past, so I'll let him take it away.
All right. Thank you so much, Tina, Nicola, Ed, and everybody else at KWSQA for having me. And thank you all to all the participants for taking the time out of your day to join us. I really appreciate it. And good just good afternoon to you, probably. But it is so all of these time zones get so confusing. And there might be, I'm just assuming that most of you are, well, just enjoying their lunch break right now. Um, it is to give you a little bit of context. I'm 6 hours in the future. The Earth still exists, so no guarantees though. But so far, so good. Um, as Lee. No, you're not Lee. You're Ed. Ed already said. My name is Bas, and I would like to talk to you a little bit about APIs, about security, and how to get started with API security testing. Ed, can you confirm once more then that you can see the world's ugliest slide deck?
Looks like it's straight out of the 60s.
Which 60s exactly?
I'll let you decide.
Awesome. So why API security testing? Basically because of the numbers on this slide. These are numbers from 2022, so a couple of years ago, but I don't think those numbers have gone down really. Over 80% of all the data that's being exchanged over the internet is exchanged through some form of APIs these days. Um, and 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 this is not really changed. Well, ever since computers came to be, you've got people with malicious intent. Let's call them hackers for the remainder of this session, who are interested in the data, and especially the data that they're not allowed, that they're not supposed to see. But unlike databases and servers and hard disks, APIs are pretty much out there in the open, especially APIs that exchange data over common internet transport protocols like HTTP. That makes APIs one of the most frequent attack vectors these days because they are so much out there in the open. The only thing you need is a way to sniff on HTTP traffic, and you could potentially have an entrance into an API. You would have thought that we would have figured out the security of those APIs and secured this data by now, but every week and on on some particular interesting weeks, maybe every day, we see news bulletins and messages. Well, oh, this or that platform suffered from a data leak. And all too often, that is because their APIs just weren't secure enough. And then again, I don't exactly know how that's in North America and Canada specifically. We here in the EU, we have GDPR, the data protection regulation something. It's basically, well, get your data security in place or else suffer from big fines. So we need to make sure that that data is secure. And we need to make sure that our APIs are secure. So we need to do some form of security testing on those APIs. And traditionally, at least in my experience, security testing has always been, oh, that's something that we leave to the experts. I've been in software testing for coming up to 19 years now, and I've always heard people talk about security testing. Oh, yeah, we're not really doing that. I don't really know anything about security. We'll leave that to the security testing experts. And to some extent, that's still true. I see then loads of teams and companies say, well, oh, yeah, we bring in security experts twice a year for a pen test and a security audit, and we pay them a ridiculous amount of money, and they tell us all the things that are wrong with our systems. And to some extent, that's still true. It is a specific niche in software testing, but especially with APIs, there's a lot that you, me, and all of us as testers can do without that deep specific knowledge or without highly customized, highly specific tools. There's actually a lot that you can do with common API testing tools. So in this talk, so most of the talk is going to be me performing tests and talking about those tests. And I'm going to do those with common API testing tools. In my case, mostly Bruno and a little bit of Postman. And all it takes really is just a healthy dose of curiosity, creativity, and common sense, which I think are characteristics of most, if not all, good software testers. So what I want to show is that yes, security testing is a specialization, but there's lots of stuff that we can do already. We just need to think about it and think of and come up with some ideas, and that's exactly what this talk is about. Because I am by no means a security expert. So let's get started. Let me get started, by the way. I completely forgot. My apologies. Starting up the API that I'm actually going to test. It's a mock API, but so I've got an endpoint here that creates a new user in some kind of system, and it's a super simple endpoint because all I need to specify is a username. And when I submit that, I see, oh, we created a new user with username John and some kind of ID. And if I create another user, it's created as well with yet another ID. So all this looks all well and good. Until we start fidgeting around with that query parameter value a little bit. So, well, ooh, what happens? How does my system respond if I leave that empty? Which is, I think, not a very exotic kind of test that we could perform. But in this case, what might happen is that you get some kind of weird error messages. Just for example, a stack trace instead of a nice error message like, oh, the username cannot be empty. We've all seen these stack traces in testing before. If you don't, either you need to up your testing game a little bit, or you're working with great developers. I'll leave that up to you which of those two camps you're in. But most of us will have seen these stack traces at some point. Some of us maybe even more often than we'd like to. The problem is not only are these annoying and not very, it's not a very nice thing to do towards our end users, but hackers can actually get lots of interesting information from these stack traces too, because they tell us, first of all, this tells me, oh, things are built in Java. Okay, that's not super interesting information, but I can see from a stack trace, I can typically see, and if I can see it, hackers can definitely see it. Oh, but you're using this and this and this library, or maybe even this and this specific version of this library. And that might tell you too much about the actual implementation of your system, because certain versions of certain libraries might have known security vulnerabilities that a hacker can then exploit. So whenever you see a stack trace like this, could be an API, could be somewhere else in your system, by the way. Don't just say, well, oh, this is not a very nice thing to show to our users, but also I think that, oh, this is also potential information that potentially this contains information that can be exploited by people with malicious intent. So that's a very quick example of things just to look out for. And all I needed to do here to retrieve that is instead of actually passing in a username, is passing in no username. It would have done the exact same thing if I would have removed the query parameter altogether. Yeah, by the way. So this is just one example of a system exposing sensitive implementation details. Another example of this, some APIs have a habit of returning the information about the server that served up the response. So, for example, oh, this used, especially PHP is very good at doing this. So, oh, we're using PHP version this and this and this with this specific framework. Um, that's all information that can be exploited, abused by people who are after your data. So you might want to be a little bit more careful as an API development team with what kind of information am I actually exposing? Next up, injection. Um, so injection is the practice of trying to insert potentially malicious data into a system. So let me take another example here. Say, for example, if I want to create a new student in a student administration system and I enter their first name, last name, and a major, this is what I want to see. So it's created. What I do not want to see is, for example, if I inject some kind of, this is not super malicious JavaScript, but it's annoying. If I try and insert a little script here, I do not want to see something like this. I do not want my systems to just accept this kind of input. Why not? Because if these kinds of values are stored in a database somewhere and retrieved maybe not by an API but inside a browser, it can do all kinds of interesting things in a browser. So the good news is most API development frameworks and lots of technology that, for example, gateways, they come pre-configured with logic that filters this out, but there's all kinds of ways to disable that, or maybe your team or company is not using those kinds of standardized libraries, frameworks, and tools yet. So it's definitely worth seeing, well, is there anything I, is there any way to inject potentially malicious data? So this is an example of what people call cross-site scripting or JavaScript injection. Let me see if I can quickly pull this one up. This is another example. You might have seen this comic before, where someone injected another piece of SQL into a system, and this could just have happened through an API as well, which is a great way to delete data in a system, for example. So please make sure that your APIs do not accept this kind of input. If you're looking for some inspiration here on interesting, potentially malicious inputs, the big list of naughty strings is a great one. You might have seen this before. You might not have, but this is a long list. Let me zoom in here a little of all kinds of interesting values. And if I scroll, weird characters, emojis, but also examples of potentially malicious JavaScript. And further down, there's some potentially malicious SQL or potentially malicious server-side commands, which could be injected into a remote system through an API. So it's a good idea to see, um, and it's wise to do this in a testing environment and not in your production environment to see how is my API, my system actually handling this kind of input. Because one thing you don't want to end up with is like eBay did in 2016. Um, they had a specific endpoint that redirected users to different pages on the platform using a URL query parameter in their system, but the value of that parameter was not validated, which enabled hackers to inject all kinds of interesting JavaScript snippets, gaining access to people's merchant accounts and changing all kinds of data simply because the engineers at eBay forgot to sanitize their inputs. So this is one of the first things I would be interested in when I test an API. How does it handle potentially malicious input? Does it actively reject it? Because it should. Um, because if not, things like this might just happen. Um, let's go to some more different types of vulnerabilities. Um, how you might be familiar with OWASP. OWASP is the Open Web Application Security Project. It's a consortium, a group of security practitioners and researchers. And one of the things they do is they keep lists of common security vulnerabilities. So they've had the general OWASP security vulnerability top 10 for ages now. And since 2019, they're also keeping a list of security vulnerabilities specific to APIs, just because APIs are becoming such a common attack factor. So the most recent version of that list was published in 2023. You can find it here. Just Google for OWASP API Security Top 10. This will probably be the number one and number two hit. I'll also send the people at KWSK the slides afterwards. So if you want to and if you can, please feel free to forward them to everybody who signed up and is attending. So you'll have the links in that slide deck too. And in the remainder of the session, I want to talk about some of the most common API security vulnerabilities that can be found on this list. And a big one, the biggest one actually, is this one: finding data that you shouldn't have access to based on who you are. Let me give you two examples, actually. Let me start with this one. So imagine we're a bank account user. I am Susie. I don't really look like a Susie, just shit. I'm Susie for now. I'm authenticating as Susie, and I'm looking to retrieve data about my bank account. I know bank account number 543 is my bank account, and when I try to retrieve that data, it shows me indeed that this is my bank account. I am Susie Jones, and this sort of kind of looks like my balance. So that's all good. The interesting thing here is this account number, because it really looks like just an auto-incremented number, which means I can probably also try and see what happens if I and please keep in mind, Susie only has a single bank account for this bank. 543 is her only bank account. So she should not be able to see this any data for this bank account, which is true. By the way, this is a good security practice, returning a 404. Because this exposes the least amount of information about your system. And there is a dedicated HTTP status code for, oh, there is data, but you're not authorized to see it, which is an HTTP 401. That's literally unauthorized. But the more public your API is, the less you want to communicate, the less sensitive information you want to communicate. And this is the way to, because this might mean, oh, 542 doesn't exist, or 542 exists, but you're just not allowed to see it. So returning a 404 in these cases, especially for relatively public APIs or really public APIs, is a good practice. But as a API security tester or as a hacker, I could, of course, very easily parameterize this one. And say, well, okay, I cannot see 542, but maybe somewhere else in the system, there is some data that I can actually see. So I am going to quickly select a file with a list of potentially valid account numbers, only run this one, and then just iterate, try and retrieve the data for all the account numbers between 500 and 599, which is a very simple, straightforward test. Again, it's literally 2 minutes to set up in a tool like Postman. What I would expect is 99 occurrences of a 404 and just one occurrence of an HTTP 200. So I added an assertion for the 404. So I should see 99 passed tests and one failed one, because I can actually see the data for account number 543. When I run that test, I can immediately see, oh, there might be a problem here. Or maybe not a problem, but there might be some interesting information here. So if I filter it, I can see that, okay, this is the one that I expected. I expected to see a 200 for account number 543 because that's my account. But it turns out I can also see data associated with account 572. And again, please keep in mind, I'm still authenticating. I'm still using Susie's token, authenticating as Susie. But I've now found out that I can also see the account data for Andrew. Susie has no idea who Andrew is, but she can see his bank account data, his bank account details now, just through a very simple experiment, just iterating over a list of potentially valid and potentially existing resource IDs, in this case, account IDs. So that's one way of finding out if there's data that you can see that you're not supposed or allowed to see. The other example is, let's say we have a burger shop and we want to see our sales data. So, and we use some kind of SaaS platform to manage all of our accounting and all that stuff. I'm the owner of Bob's Burgers, and I see, oh, I'm not really doing so well. And of course, I'm also interested to see how my competitors are doing. Is this just a general downturn in the economy, or do my burgers just suck? So one way to do it is say, well, maybe there's an endpoint that I can see that I should not even be allowed to add, that gives me a list of all burger joints that use this system. Turns out, in this case, of course, because I prepared it this way, there is. And I can see other kinds of burger shops too, and then say, well, ooh, but maybe let's see how the peach pit is doing. I'm really hoping that there's some people old enough to know, okay, thank you, Ed, to know where I got that reference from. Thank you. Anyway, here too, by the way, I didn't even tell you, I'm authenticating as Bob, so I should be able to see the data for Bob's Burgers, but I should definitely not be able to see the sales data for these other burger joints. But I can, just because I was able to retrieve a list of all the valid resource IDs. Here, the resource ID, the name of the ID of this customer. It's maybe not something that you can guess, like we did with the account numbers, but it's a list that is findable. These are two examples of what OWASP calls BOLA, or broken object level authorization. This is a very complex name to say, well, you're able to see data that based on who you are, based on who you say you are through authentication, you're not supposed to see. And in the 2023 OWASP API Security Top 10 list, this is the #1 vulnerability. This is basically what a data leak is. I'm allowed to see data that based on who I am, I'm not supposed to be able to see. Those examples, of course, are fabricated, but these things happen in real life often. So things to look out for as testers, if you want to be aware of this kind of vulnerability, is can I predict or find resource IDs? And especially for resources and pieces of data that are not mine to see. Another thing to keep in mind here is that, and especially if I'm going to guess resource IDs, which I did with the account numbers, I was able to just send 100 requests in a very short amount of time. And the real and proper hackers, not like me who's just giving a demo here, will do this with thousands or tens of thousands of requests and numbers. Your API should have a mechanism to prevent people from submitting a lot of requests in a short amount of time. Because it helps you prevent distributed denial of service attacks, but also because it makes it harder for hackers to just try and scrape data or try and find data that they're not supposed to see. The mechanism that typically is put in place to this is called rate limiting, and a lack of rate limiting is another vulnerability on this list, #4 actually. So unrestricted resource consumption in OWASP terminology is when your API just allows you to send as many requests to it in a short time frame as you want. And so rate limiting is another measure. It's not foolproof, but it's another security measure that makes it harder for hackers, for people with malicious intent, to try and abuse and misuse your system through the APIs. Does this happen in real life? Yes, it happened to the US Postal Service in 2018. They had a security, well, they fixed it, but they had a security vulnerability where every user of the system who had an account on the system was able to see all the account data for all 60 million other users, which is a pretty interesting and pretty big problem. And this is a prime example of broken object level authorization. So you log in as user A and you're able to see the data of user B and C and all 60 million other users. That's a problem. The next question I would ask. By the way, we didn't coordinate this beforehand, Ed and Tina, but I'm sure you're going to give me a heads up a couple of minutes before you really want me to stop talking.
Yeah, we will.
Okay, gotcha. Otherwise, I'll just keep on going. No worries. Now, at some point, I run out of slides, but maybe you'll probably run out of time before I run out of slides. So, good. If we can see data, which we did just now, maybe there's a way to modify it too. I've got another example of that. So let's say we have a system where I can see, what are the fines that I received and that I still need to pay. And here's, oh, no, this is a fine that I need to pay. I don't like paying fines. Nobody really does, I think. So maybe there's a way to modify this data and just make it go away instead of paying it. So typically, if I look at API documentation, you will see the allowed operations. So the endpoints that are exposed and the operations that you can perform on those endpoints. That doesn't mean that those are the only operations that are implemented. It's just that those are only the operations they want you to be aware of, they want you to know of. It might just be that there's other kinds of endpoints. For example, those that were just built for testing purposes and that people forgot to not deploy in production, and they end up in production too. So, for example, I could see, well, I don't want to pay this fine. Maybe I can just delete it. Okay, that doesn't work. I forgot it again. Let me quickly copy this because that saves me a lot of typing. Maybe I can just override it with another version. Say, let's just override this. No, doesn't work. Another way to override this, just put it, also doesn't work. But maybe I can patch it. And with a patch, you typically only supply the fields that you actually want to update. So I would expect a 405 to happen here as well. So, oh no, you're not allowed to do this. Oh, that was not supposed to happen. So this might be an endpoint or an operation that is not documented, but that still exists. And this is just, again, makes it, oh, these are common, and these are commonly generated operations, and maybe people just forgot to disable or remove them again. But what happened now is that when I try and retrieve this fine, it has suddenly disappeared without me actually paying the fine, which is probably not the idea behind this system. This is a quick example of being able to modify data that I shouldn't be allowed to modify, or at least not modify in this way. And that's an example of what OWASP calls broken function level authorization, or I'm not going to BFLA, BFLA, which is number 5 on the OWASP API Security Top 10 list. Another example of this would be admin endpoints that are accessible to regular users, for example. So if there's a certain kind of admin endpoint that you should only be able to access and use with elevated admin permissions, but that you can use with a regular user account, that's another example of this kind of vulnerability. Those two vulnerabilities, so broken object level authorization and the ability to see data that you're not allowed to see, and the ability to manipulate data that you're not allowed to manipulate, both have the same root cause, a broken role-based access control implementation, which means that if you stumble upon data that you're not supposed to see when you're testing APIs, it's probably a good idea to also see, well, what else can I do with that data? Because you've just demonstrated that the role-based access implementation, role-based access control implementation in your system has a weakness. So by all means, report it right away. But it's wise to dive a little deep and see, well, oh, if I can see this data that I'm not supposed to see, what else can I do with that data? Because both are role-based access control and authorization related. Um, a real life example of a broken function level authorization, the ability to buy one type of cryptocurrency with another type of cryptocurrency that you don't own, which happened to Coinbase, one of the largest cryptocurrency trading platforms out there in February. It doesn't say what year. Um, I don't think this is too long ago. It is definitely not this year because I've been using this image for longer than that. I don't know which exact, but this is another example. So I'm using something I don't own to sell something I also don't own, um, but I'm still allowed to do that. So this is yet another example of being able to manipulate data in a system. In this case, selling something that's not mine, um, uh, all due to a problem with authorization or role-based access control. Um, Next up, a different type of vulnerability. Let's have a look at ordering a game. So, and for the game, an example, FIFA 24. I can post a new order to a game shop. It's a FIFA 24. Okay, I can order one copy of FIFA 24. I can also order 100 copies if I want to. I don't know why you would want 100 copies of FIFA 24, but one's more than enough. I think uh, this is just accepted behavior. Let's imagine that this game shop has a limited stock of some kind of rare game. Let's say, for example, Gamma Attack. Um, Wikipedia told me this is the world's rarest video game. I've never heard of it, never seen it, never played it. There's supposed to be only one copy left, um, somewhere in a safe with a way too rich American guy. The problem is the console on which it's supposed to be played doesn't exist anymore. Um, so it's that rare. Anyway, I just needed an example. So if I, and this is because it's a limited edition, this game shop says, well, it is strictly one copy per customer only. So if I try to order 100 copies of this one, it says no. I can order a single copy, though. Which might lead you to believe, okay, everything is fine. Customers can only buy a single copy. What we forgot to A, identify, B, design for, C, develop, and D, test for, though, is what happens if I just place multiple orders as a single user, each time ordering just a single copy. And all of these are accepted. I can do this for a very long time. Um, and, and this is an example of where we didn't really think of all the different ways in which people who use the API can abuse or go around, circumvent certain kind of business rules or restrictions that should apply in the system. There's a name for that specific type of There's a name for that specific vulnerability too, and that's unrestricted access to sensitive business flows. So there's not necessarily a problem with me being able to see data that I'm not supposed to see or manipulate data, but the way my API is designed allows me to work around certain kind of restrictions. For example, a limited number of copies per customer in this case. Another example of a vulnerability like this would be abusing a ticket sales system by just hammering it with orders as soon as Taylor Swift tickets go on sale, for example. Or, well, any other artist of your choice. So that is another example of unrestricted access to sensitive business flows. So the way to deal with that as testers, as development teams, is first of all, involve the testers from the start, because they are typically the ones who think of all the interesting ways in which people can actually use, misuse, abuse systems through APIs. So identify what are my sensitive business flows and how could people abuse it? And then take prevention measures. And those prevention measures, for example, could be in the think of the ticket sales systems again, trying to detect non-human patterns. So if someone puts items in a shopping cart and then it goes to the checkout and hits the checkout button within the second, you're probably dealing with a script here and not with a human being. Or just someone who really wants to go to see Taylor Swift. But if that happens a lot of the time, you're probably dealing with the bot, and you should probably block that. You should probably say, well, oh, I don't think we want that behavior to be possible. Or maybe you want to use a captcha on some other type of am I really human detection of am I really a human being? None of these mechanisms, by the way, are guarantees that they will make your API safe or secure, which is commonly referred to as the Swiss cheese model or the Swiss cheese analogy. You should think of security measures like things like human detection or non-human detection, device fingerprinting, putting role-based access control in place, putting rate limiting in place, as adding slices of Swiss cheese in front of your system. So none of these security measures are guaranteed to make your system 100% secure. But if you put enough of these in place, it is very likely, you should of course still test for it, but it's likely that the risk of people abusing your system will go down to an acceptable level. So again, none of these security measures individually will make your API and the systems behind it 100% secure. But if you combine them and configure them properly, they will very likely help you get that risk down to acceptable levels. Seeing that we're coming up to 1 p.m. on your end, I am going to skip this one and just wrap up. Do I have 2 more minutes, Ed?
Yeah, we have about 7 minutes left, so yeah.
Okay.
If you
So
want to give
I
a few
want to
minutes for
give you a
questions.
bit of time to wrap up and questions. So this was just some examples of techniques that you can use to test for common API security vulnerabilities, just to show you that you don't need deep security testing knowledge or highly specialized API security testing tools. You can do a lot just with common tools like Postman or Bruno or just an API testing library of your choice. There's a couple of entries we've missed. I'm not going to go over all of them. Again, you can find them with descriptions and all of that on the OWASP website. But there's one resource that I quickly want to highlight. That's APISec University, which is this one. I really like this site because it provides free courses on API security. They are curated, which means they are of good to very good quality. Again, they're all free. There are some certificates associated with which do cost a bit, but they're not too expensive. But all of the materials, so all of the videos and all of the reading material, and with this one, which I'm trying to work myself through right now, there's lots of hands-on actual API testing, API security testing practice as well. And all of this is completely free. So if you want to dive a little deeper into this specific topic, I'd recommend starting with these two courses. So the API Security Fundamentals and a course that covers the top 10, and then maybe move on to something more specific like API penetration testing, or maybe you're interested in securing large language models, for example. So there's lots of stuff to explore there. And that's the trigger for me to stop talking and see if there are any questions or comments or feedback or stories that people want to share.
Thank you, Bas. Great to hear that. And yeah, if anyone has any questions, feel free to unmute yourself and ask or type them in the chat. I don't know, Bas. Are you able to see the chat there?
So if I stop sharing, I should be. Yes.
Hi, Bas. This is Nathan. I'm new to the API testing overall. Is there a way, if the API is not documented, is there a way to hack the APIs? Is there a way to find the APIs, first of all, list of APIs?
So one very quick way to start is, if I'm working with a web application, is just opening the network, the dev tools in my browser, go to the network tab and see what happens if you submit a form, for example, because it's highly likely that it will just call an API that sends the data that you put into the form into a backend, and that's a great starting point. There's lots of common practices. There's not a lot of standards in APIs, and there's definitely not in REST, but there's lots of common practices and common structures for APIs and the way endpoints look and the way request payloads look that you can use. Of course, that requires some prior knowledge. One of the courses, so the API penetration testing course from APISec University actually starts with an answer to this specific question. And it is all about API discovery. Is how can I find out more about endpoints when they are not documented?
Okay, thanks. Yeah, that is what I wanted to learn.
Awesome. Thank you for asking, Nathan.
Thank you.
Jeremy.
Hey, Jeremy.
Sorry, just to follow up on that question, have you come across any tools that you've used for API enumeration? Same idea, like discovery and stuff like that.
No, not really. I know, and again, I'm trying to find the time to work through that API and that API penetration testing course. The problem is there's so many things to do, so little time.
Yeah.
I know that I saw your comment in just now. Burp suit is a great one. Zap is and the Z attack proxy is a good one too. That has a lot of intelligence there. Another one that I would maybe highlight that I want to highlight is from the same. Okay, by the way, these people do not pay me to promote their stuff. It's just resources. I think it's in here. They have a free security scanner that you can integrate into your build pipeline, and that explicitly scans for the top 10 API security vulnerabilities, which might be something that is worth checking out too. I've not had, and I keep on finding myself out. I should really find the time to try this out for myself, so I can actually say something decent about it. I know it exists. I've not found the time to try it out myself yet, but it's given the quality of the core, it's definitely worth checking out at least. And I like the word free. I'm Dutch. I like the word free. So I hope that helps, Jeremy. Thank you.
Yeah, no, thanks. I have experience with both those tools. But oh, sorry, not this one, but
Okay.
Burp and Zap.
Yeah. Awesome. Thank you for the recommendation in the chat, by the way. Appreciate it. I think we're right on our closing time, Ed, aren't we?
Yeah.
I don't know if you have any final words. I do have one more slide, and that's just if something comes up, any questions, feedback, whatever, things you want to share. LinkedIn works. I spend way too much time on there. Email works. So by all means, I'd love to stay in touch. And I'll stop talking now, but only after thanking you all once again for taking the time out of your day to join us. And thank you, Nicola, Tina, Ed, and the rest of the folks at KWSQA for having me and for running these events.
And thank you all for joining us, and thank you, Bas, for taking time out of your day to go over this. Appreciate it. And
it's been a
like I said,
pleasure.
you'll get a survey probably within the next couple hours to give feedback that helps us plan events. If there's any feedback for Bas directly, it'll go to him too. So appreciate all your time.
Yes.
And we will have a recording. It will be unlisted on our YouTube, but we'll share the link out if you reach out to us. Okay. Thanks, everyone. Enjoy the rest of your day.
Have a wonderful day, folks.
Thank you.
Cheers.
Take care.
Bye.
Bye-bye.